He bought the property and was unsuccessful. And converted it to a hotel, and then converted that to a school, and it became known as the Roanoke Female Seminary. So back in the days, all kinds of schools that were like secondary schools were called seminaries. It doesn't mean you're going to learn to be a preacher or a priest. And actually, a lot of those things called female seminaries were what you would refer to as a finishing school. Do you know what a finishing school is?
High school?
Finishing school is like a secondary school where you send women, or a school. A lot of women weren't formally schooled outside of their home prior to going to a seminary. So you'd go to the finishing school, and they would basically make sure that you knew how to be a lady, that your manners were correct. You would learn, you'd learn make sure you had your reading at the correct level and all that sort of stuff, but it was less academic and more social training. So that when you left the seminary, you'd be ready for your husband, because that's what we do back in the day. And then in 1842, the property, the buildings, 600 acres, was purchased by this organization called the Valley Union Seminary, which happened to be a Baptist organization. And it was founded that same year, and it became, anybody want to guess?
1842.
Nobody wants to guess?
No.
Go figure, that fell today. Yes. So this says Carver, but it's actually incorrect. It's Carbon. They just, for whatever reason, that wasn't corrected in the Wikipedia page. So that spring house where people would go and sit and soak in the warm, smelly water is still there. So by 1873, Botetourt had a post office. That is what makes a town, by the way. You're not really like an official town. You got a post office. That's a big flipping deal to get a post office. And it was accessible by traveling 9 miles on a turnpike that led from the Virginia-Tennessee Railroad. Remember I said there's a railroad hub nearby? Do you know where the railroad hub is? Roanoke. Right? Downtown Roanoke, Virginia. It's just like Atlanta. Roanoke is a railway town. Why is there a city in the middle of nowhere, Georgia? We don't have water. Like, what's the big deal with us here? Atlanta is a railway hub. Same thing with Roanoke. And today it's part of this suburb they call Old Fields in northern Roanoke. That's what remains of Botetourt. Now, here's cool stuff. So this is 1842-ish images of what Botetourt Springs looked like when it was sold to Valley Union Seminary and became Hollins. So these are the old pictures. This is a colorized version, pretty similar to the first one, but I mean, look, horse and carriages. Look at the horse and carriage. And I can tell by looking at these dresses, those dresses are what you would call, that's Victorian style with the bustle in the back. So that's turn of the century. So you're looking somewhere about 1880 to 1910, maybe, from when this picture was done. And that's just a color painting, obviously.
And what year did Tinker Day start?
Tinker Day started in let me get the exact date. 18, I can give you the exact date. It's like 170 some odd years now. So,
I'm not doing math.
I would have to look it up exactly, but it's old.
I'm not doing
Been doing it for,
Where's Tinker Day for?
we're on Tinker Day. I'll get you the exact date. I have it. It's in one of those books over there, actually. So this is what it looked like before. And obviously it looks a little different now, but this is the same building. If you look at this building right here and you look at it in this picture, you see the little cupola on top and the clock. So that building is that building, which is main building, and that cupola is no longer on top. But here's the cool thing. That's the spring house. Okay, so the class of 79 restored it. And so this is like the little area where you would go and see how you would go down into that little pit and just sit there and soak. And that's the original spring house from the 1820s.
So it still stinks?
Well, no, because the spring is closed off, thank God, because that would be really bad. This is how the spring house looks right now. And so, and this door, like right below this door, this is what it'd be here, these little steps that go down. And it's like a little garden. It's pretty cool. And just two more maps. Here's another nice old map. This is hilarious. Look, this is like, this is what we call things in the 1920s because it's cute or whatever. So today, if you were to look for the spring house, I think it's so funny that this Warm Springs lesson occurred like right in the middle of my, hold on, do it this way. So if you were to look for it today and you wanted to find your spring house, it would be right about,
It's right there.
Yeah, right about there, right? Yeah, right there. No, it would be right about here. This building, okay, so here's the main, this is the main quad right here. So a minute ago when I said that building has no cupola anymore, that's this building right, kind of whitish looking one right here, long ways.
Hmm.
And see this one with the dome, it's octagonal, the building is octagonal, that's called Botetourt. It's one of the few antebellum octagonal buildings that survived in Virginia. And the spring house is right there. That little white dot is the roof of the spring house. So it's still there. So you can still go and say, oh, look, spring house from the 1920s. Just like we had,
Yeah, bathroom, right?
Hmm?
No bathroom.
no bathroom in there. Interestingly, finding a men's room on campus is rather difficult. There are men's rooms in the educational buildings, classroom buildings, and there is a men's room downstairs in the, it's called Moody Center. That's where the cafeteria is and that kind of business. And downstairs is like the bookstore. There's a men's room down there because they have social things in there. And that's about it. Like, good luck if you're in a dorm and you want to visit. Somebody will actually flip a sign on the door that says there's that's how it works. At least that's how it worked in the 90s. So anybody have any questions about today's lab? Are we good? All right, yes.
I don't have a question,
Okay.
but off of what Drew said and walking and biking and stuff, but not biking, but mine's about biking. There's
Uh-huh.
a guy in 2020.
Uh-huh.
And he went on a bike ride from Washington to, I think, North Carolina, not sure. And
Mhm.
you're probably like, wow, did he do that for a friend, cancer or something like that? Really nice. No, he wanted to go from Poo Point Trail, Washington
Yeah,
to Peachtree Creek, I think, North Carolina.
that's pretty awesome.
That's about.
That is pretty cool.
uh,
So this, by the way, is this is my favorite Tinker Day image.
Yeah.
That's a historic Tinker Day image. And if you think about this, you're talking about, I mean, again, I think this picture's from like 1880 something. So those women are in full wool skirts and they have leather boots with probably, I don't know, wood in the soles. And
Burning.
yeah, oh yeah. And they're climbing up a mountain and helping each other up. Look at the shoes on the one that's doing the helping. Yeah, that's what you climb in.
So much.
Uh-huh.
So why did Tinker Day even get invented?
You know, I don't
That
think
is a
anybody
question.
really knows why it got invented. It just kind of
It's
did
just
over
cool,
time.
and
It
it-
just did. And it's been going on for over 150 years. So we're all like, time to do it again. All
College it was like.
right. So if,
College was like, oh, this would be fun.
yeah, I guess so. I actually think it's probably teachers that did it truthfully. So
We get a
anyway,
day off.
if you're a junior, you are excused. And if you are a lab rat level, hang on just a second. We're going to start our lesson and I want to make sure you guys have your Q2 packets. Does this belong to anyone? Anyone missing their,
I mean, I'll take it. but-
you had one, I think, though.
Yeah, I'll take it.
You have one, I thought. You can go. You're good. So I'll see you next week. You can't go, Jack. You're still in
Well, I'm
class.
getting my food.
No, you're not. Yeah, I see you.
I think I'm accepting.
Is-
Oh, yeah. I need to do like I haven't heard in my life. I need to get my food and take a quick walk.
How are you? Alright, cool. Bye, so see you next week. Under the sink. Yep. Okay, people. I'm gonna answer his question.
Yeah, that whole Cooper Point thing with.
That's very fascinating.
I've never met that guy in Hartwell.
Yeah, me too. I
I
like him.
wanted to be my friend.
He sounds like a fun fellow. I like people with a sense of humor.
Like, I remember that the rest of my life, like, I heard.
You what?
I know.
It's fine. They'll come at some point.
I know, right?
Yeah, you could.
If you wake up at you can
I
probably
just
hear
think what my Google
you
does.
can probably hear when she pulls up.
Yeah, you check me. What am I?
What's fun?
Here you go.
I can't even see.
Jack,
Oh, my subway chair, okay? I had any time. You gotta go.
answer your question for you, Jack, because I can never remember the date because I'm not good with numbers.
Oh, yeah, you can just share. You can just, yeah, you can just share. And I'll share it to you, I'll share my contact.
49, 130.
And it'll just pop up as middle of
Is Jackson, was Jackson, was that?
No, it's literally just.
It's just Jackson.
My mom has a thing with 4 letters in the
I'll
name.
talk to you later. See you. Have a good day.
See you later.
All my siblings are 4 letters in the name. My mom's rule. Yeah, so my mom's rule.
If you don't have a Jack up, oh, there's an 8.
Yeah, 4 letters and an A.
An A, but A not at the end.
No, it has to have an
Has
A.
to make
4
it
letters.
Right, why?
My mom was like, apparently got really mad writing your name in school, so she's like, we're just gonna have your name be really short, and then she just didn't put us.
Elizabeth was just too much
And
fun.
then she also didn't put us in public school, so that was really like.
Ah,
All my siblings are I'm Liam.
Yeah.
My
Liam,
brothers and
Lucy.
sisters Lucy and Louie.
Yeah.
And like literally daily, they get our names mixed up.
So that's when my,
I would get your names mixed up. I do it funny even though they're not.
You called me Mitchell. You called me.
I called you Mitchell a couple times, so I got you straight. A little bit.
It doesn't have an L.
that's why when my youngest sibling came along, it was like, man, all these
We all have
names, but
names.
we have to cut it down to 4 and an A. So then we got Rita, and
Alex doesn't
now
have-
she's,
His full name's Alexander. It has an E at the.
Yeah.
You will
Made an
pay.
announcement that I claimed this.
You claimed it, who said?
I mean,
so this is James's grave table, and this is my subway chair, alright, now, don't fall in line.
and this is my pillow couch.
That is your pillow
You
couch.
pillow
Now,
couch.
normally it's me and Alex's.
I know,
Back before they used to wear funky clothes, which they have not always done.
you guys had.
This is a picture of the Tinker Day proclamation, careful, which I will share later today. That's when the president gets out on the front porch of this, of main building here and says.
And
it's
tells you
Tinker Day.
to today.
Tells, yes, there's a whole big thing that she has to say, and it talks about how classes are canceled and the illustrious
Kreme.
faculty and staff, and I mean, it's funny. Yeah, and then, well, you do that first, you do the Krispy Kreme first.
Yeah, that's the more important thing.
Yeah, because you wake up to the bells ringing and then you go eat your Krispy Kreme and then you get dressed and come here. But prior to that, before they got dressed, they would all just show up here ready to hike. And then that shows the front of beginning of the hike. And then this is great. I love this picture. It's like they're trying to see who's gonna be first of the, the mountain, which is kind of crazy.
Is there a reward for somebody who
No.
can do it first?
No, but in my book over here,
No,
I have
it's
a.
bragging rights.
Yeah, it kind of is. I have in this awful tacky 90s scrapbook. I actually have a picture of
The pillow
who
with the-
made it to the top.
It did look like. oh,
Yeah,
this one.
it's fluffy, cause it's 90s, puffy paint and whatever. I did not climb my freshman year, my senior year, because I had, my ankle was a little jacked up. But my friend made it to the top first and I got her picture. Cause this is. Tinker Day there. Back, but anyway, she made it to the top first and, we always called her Superwoman. That was just our nickname for her because she was just always doing amazing stuff. And she actually, is a doctor now. And I saw her recently when we visited Michigan and she's doing great. Don't fight over the pillows, y'all. I don't know where the picture of her is. I swear I should.
And all of a sudden, there was a pillow battle way out.
Oh, wait, there's more to do. Okay, so here's, let's see,
See what happens when
This
we don't have.
is-
friends. It's so unpeaceful.
gotta hide this picture. This bottom one here, that's my class at the top of the mountain. You can see, not very big group of people, that's my class. Those are, oh, there she is, that's my friend Christy reaching the very top, she was the first one up. She's like, I couldn't climb, I took the van up, which meant I got to stand at the top of the hill and see who climbed up first, and it was Christy.
So you got up the hill
Here's-
first.
Yeah, the van people, this is the view from the top when you get to the top of Tinker, it's gorgeous. Beautiful, beautiful, beautiful.
We're supposed to be seniors.
That's
What's
me
going
because I
on?
got to ring the bell. I got to ring the bell my senior year, so that, guys,
There
leave the
must be
pillows.
balance.
Quit, stop. Yep,
There must
that's
be
my,
balance.
so that's my senior year, I was
I think.
special, got to ring the bell.
Oh,
And those are some, these are all friends of mine on Tinker Day doing, that's not Tinker Day, that's ring night, but these are Tinker Day.
What?
These two were like, they actually had both broken a leg.
Oh.
It was funny, they dressed up the same, but they, because they looked alike anyway. They're goofy. So anywho, awesome Tinker Day, lots of fun. And we will start our lesson, but
Okay.
first, I'm giving you your Q2 packets.
this is-
Who was not here last week and did not get a, syllabus, Q2 syllabus?
I forgot to pick mine up.
Okay, I'll be sure I give
Yeah, I
that
was
to
in
you.
the zoo. I was in the zoo.
You were in the zoo? Oh, in the Zoom. Yes, you were. You were in the Zoom. Caitlin, you got yours because James wrote it home? Okay, here is, I'm gonna hand you that together.
I've been tasked with bringing Alex and Bailey's home.
Yes, okay.
Sitting on the couch sick and he was like here and he threw it out.
That's so nice of him. Okay,
good
so
job.
here's Q2 along with,
Wait, is he both of them in there?
hey, yes, that is your new syllabus and your second quarter packet. So your syllabus now extends through second quarter, so you basically, you take those 2 pages that are syllabus, and you put them behind your current syllabus.
These?
Yep, and then you put the rest of it in the very back of your binder. Because it's the remainder, yes.
So this is the first Tuesday I've been here that Tinker Day was here.
First time we've had to figure it out what you did,
Yeah,
teaching.
so does this screen count as points on my midterm? Okay, just making sure. Just make sure I get point. I was under.
I'm gonna hand you
Didn't
Q2,
have a point.
and I'm gonna give you some more. That's really cute. You went all out and did it. All
Do I
right,
get- So I didn't.
2 more.
Do I get the point for the
Yeah, you're really gold.
no, it's yellow. but-
That's close enough, dude.
Can I just
She
get an
said yes, why are you
Can I
fighting?
get an extra point for Mario, please?
Dude, Mario on the mountain, he steps on mushrooms. There you go.
Daddy,
Yeah,
No,
so
he defeats Bowser though.
Okay, but stand up, stand up.
Mario didn't climb out. Oh, sure.
He gets high.
He grows, he grows a cat tail and flies up the mountain. That's what you
He
do.
gets high.
He gets high rooms.
All right,
He gets high, baby.
yes, yes, I'm sorry, I should have given you an extra.
He literally gets high too, so he gets tall.
Okay. All right,
Yeah, I guess high
everybody's
insurance.
siblings have what they need to get to do. Okay,
I
so
Miss Danny, he does get high in shrooms.
I don't know about that.
Because he gets taller.
I know nothing about it.
He grows. He grows.
He gets
cat tail.
taller, he does. It's a little, yeah. So anyway, if you handed me in a lab or extra credit, anything last week, I didn't get a chance to look over that yet because it's been kind of a nutty week. But if you've done that, just wait, you'll get it graded this week and you get extra credit added this week. So be sure that you do keep up this week because you have a test and everything at the end of this week. You have your unit test. Keep up because this is the end of Q2. So by next week, you'll get your, Q1, sorry, beginning of Q2. I did that earlier. Gosh,
You said
I
no
know.
more.
Early
my brain is dead. You have no idea the week I've had. Oh, that's gonna scratch. You bleeding?
One left is Q3.
It's a good one.
That's cute.
Ooh, that's an expensive piece of glass to lift up and drop down too. I'm impressed.
Q2.
I did it.
Last one left is Q3 that you need to say.
Yes.
Or you got to.
I Q3 here, I'll say it. Q3 starts in January. All right, so anyway, you want to keep up this week and you want to double check everything because once your unit test is done, and then I'm pretty much able to issue your grade, right? So you need to be sure that you're keeping up because if you get behind this week, your Q1 progress report is gonna show it.
Is lab 7 extra credit?
7 was mandatory, 8 was extra credit. 7 was the Zoom.
Yeah.
8 is the extra credit one. I think it's analyzing watersheds. There you go.
Yeah.
Piper, get her done.
And then,
Yeah, there's this little stack over here.
Well, you will have the caffeine.
yes, I've already had 100 milligrams today.
So anyway, I'm super thrilled we had a class day with Tinker Day. It's never happened before. It's the most amazing thing ever. So anyway, we will get started for today's real lesson. We have to do real school now. If we were at Hollins, there would not be real school today, but sorry, y'all pay me for school, so you gotta have real school today.
But donuts.
I know, I gave you donuts, but it's really cool when you have like a test scheduled and you get an extra day of studying, that's awesome.
Can I at least have a third donut?
Maybe when we're done with class, because I don't want to keep them all.
All
right, so goodbye, you awesome Tinker Day ladies whose picture was taken in. I will tell you the exact date on that one, because that's an awesome picture. 18
They are
something.
baking.
Oh
That's
yeah,
what
they
the
are
record.
baking. There is no doubt that they are absolutely baking. I don't want to do that.
And the thing is, they're probably having a great time.
Yeah.
Oh, they are. They're smiling again. They're like,
So think about all the times you complained about how hot it is, and then the ticket those ladies currently
Yeah.
literally baking themselves and having the time of their lives. That's
out
cool.
there on top of the rocks in wool clothes, not the way anyone wants to be.
Or protein.
But hey, man, they did it. Oh, and the cow. Real quick.
25 cheese.
49.
That
That picture was taken in.
That picture right there.
Yeah, that picture up there on the screen was taken in
What do they do?
1898.
Oh,
That's what you wear.
the
in-
nineties.
Yeah, it is the 90s, 1898, which is a heck of a way to be out there hauling around. And it said that the Carbon House was still on campus, and it is. I actually worked in the Carbon House my freshman year.
What'd you do?
I worked in the alumni office and helped basically, I filed actual papers all day long because, back then, you know, we didn't have it wasn't all electronic communication in the 90s. We had a lot of paperwork. So we had alumni that would they would like write a letter to the school, and we had to save absolutely everything because we didn't want, you know, you don't want to ignore something that somebody had sent. So we spent all that time filing stuff, and basically I had like the worst cuticles on the planet because it's just shredded trying to be there, trying to shove stuff in. But yeah, this is Carbon House, how it used to look, and there's a door now, and it's still there. Guys, pillows alone, and you make money, you sit on the floor.
Shoot him with the Nerf gun.
Yeah, that's coming. Alex barely missed it last week. All right, so let's go into a real lesson. Here we go. So we're gonna cover earth surfaces or surface processes, groundwater. Yeah.
Is this junior?
Do what, Brian? Oh, it says junior. Yeah. Oh, you caught that. I don't think it is junior though, did I?
Did I get the brownie point?
Hang on, I might just
Seeing it
open
on
the wrong
board
one.
That it said steam, not stream in one of the videos.
Yes, I gave that to you.
Yeah.
Man, we.
I don't know if I think I opened the wrong one there.
Had the loud one. Yep, last week, man, we're just wrapping it up. I
Yeah,
just had-
No, it's the right one.
Our team.
I just didn't change the typo. Good call.
Yeah.
All right, so let's do this.
I think our team is the most bad.
And Alex
Yeah.
isn't even here.
Oh.
Man, we're,
There's 2 people on the junior lab.
The junior, yeah, and the juniors are, it takes them a long time to catch up. You guys are better at seeing mistakes because you've been doing it longer.
Our last.
because we're
team.
very judgmental.
There's that. Okay, so movement and storage of groundwater. So here we've got what all the water on the earth and in Earth's crust, what do we call that, Piper?
Hydrosphere?
Yes, the hydrosphere is all the water in and on Earth. So we have a hydrosphere, that's an old one, I'm not that old. So made me sad. So we have a hydrosphere, we also have an atmosphere and a geosphere, right? We have all the spheres. And so, yeah, this is really hot here because the air conditioning's not on. I'm changing that because that's horrid.
Yeah, that was
There we go. So yeah, and biosphere, there's lots of spheres. So that is correct. We got the biosphere. So now we have 2 percentages here. What percentage of our water is salt water and what percentage is fresh water? James? 70-30. Okay, who else has a number they want to give? Parker?
73.
93, what is fresh or salt?
Salt.
93. Okay, what have you got? Okay, Liam?
75-25.
75-25. Anybody else have a guess? Milo? Huh?
I'm with James.
You're with James? Piper?
97, 99 to like 3 to 1.
97-99 or 3-1. Okay,
Let's
who? Okay, Caitlin, you got one more?
go.
You're with James?
I'm with James. too.
You're with James too? All right, so who votes there with James? And James said what, 75-25?
He said 70-30.
70-30.
75.
You said that, okay. Anybody else with Parker or Liam or Piper?
Raise your hand if you're with me.
How about Liam? How about, what, you just said that. How about Parker? How about Piper?
Are you with me?
Okay, well, the only person in this room winning any money would be Piper if this were real gambling because she's darn close. 97% of the water on Earth is salt water. Only 3%
There's a 7 and a.
is fresh water. Yeah, there's a 7 and a 3. Only 3% is fresh water. And it's contained in land masses where you've got lakes and things and glaciers. A lot of it is in glaciers, right?
There's also a lot of diseases in glaciers.
Oh, that's
And
fun.
they're melting. So
Mm.
they're
What's
getting
with all the
released.
morbid facts?
So we've got our Rico there, right? So that means you have to remember this. So here's the thing. Even if you don't ever get these exact numbers right again. If you can keep in your head for the remainder of your life that more than 95, keep that's an easy one to remember, like more than 95 is salt water. That'll help you because there are going to be points where this will come back up in other science classes or maybe even other like geography or social studies classes because it really matters. So most places in the world use their fresh water sources that are in their land masses for their drinking water, right? But Israel, by the way, which is on the ocean, do you know what they do?
They don't have any radiation spreading.
So what did they do? How did they get water? Do you know? Drinking water. You know?
They boil the soda out of it.
Yes, they
And
have
this evaporation soda.
desalinization is what that's called. So Israel is the only country, to my knowledge, that on a large scale runs desalinization for fresh water for drinking. So they take the salt out. The reason it's not done everywhere else is it's really expensive and complicated. It's not an easy thing to do. And they've mastered it. I imagine there's an expense to something else, but they've mastered it. Yeah.
When my family visited Dolphin Island and the old Civil War port there, that's what they did. They had big pots
Mm-hmm.
that they would take in, boil the water, and they would use the salt to make bread and use the water to drink.
Can you imagine how much work that would be just for a small fort, let alone a whole nation of people?
Yeah.
That's a lot, right? So if you're ever like out to sea, you can always get a little seawater, and if you got a little dome of any kind, you can let the sun evaporate it and let the drippies come down, and that's going to be fresh water.
I
Mhm.
did that science experiment as a
Did you?
child.
Yep, you can do that. So when we talk about groundwater and precipitation, what is the process of precipitation soaking or trickling into the ground to become groundwater? What do we call the process? Anybody? We call that infiltration. It's also the movement is described as percolation, but yes, it's infiltration. So when we talk about substrate, okay, substrate is going to be what? Ground, rock, soil, whatever it is. So depending on the grain size and how the grains are sorted, will tell you how much water the ground can hold. What do you think? Where are you going for, Piper? She's guessing something. She's thinking about it still. So let me ask you this. If you have a jar full of, and you fill it up with marbles, and then you pour water in it, and then you have exact same size jar, and you fill it up with sand, and then you pour water in it, which one's going to hold more water?
Sam.
You think sand? Marbles? Yeah, so when you've got more spaces between your pores, you can hold more water. So that would be your marbles would hold a whole lot more than your sand will. So the one that we're looking for here is groundwater storage, which is a little kind of tricky, but yes, the groundwater storage is your substrate porosity, and how much it's going to be able to hold is going to depend on a couple things. So we got groundwater zones. Now I'll tell you, these are written backwards if you're looking from top to bottom, like the ground is organized. So we have, look at the bottom one first. So the zone above the water table is moist, but it has air that occupies the porous spaces. And then the next one down would be the upper boundary of the zone of saturation. And then there's the one on the top, which is where all the water is. So James, give me one. Which one? Zone of aeration. Where's that going to be?
It's the bottom one.
The bottom one. Okay. What do you think?
Zone of saturation for the top one.
For the top one. Okay. What do you think? Water table for the middle one. All right. So let's see how we did. Boom. All right. So good. You guys are so smart. All right. So water table is interesting, and I'll come back to that in a second. Oh, that's so pretty. I like that. Everybody ooh and ah for a minute. Ooh. Oh.
Like my family.
Yeah, all right. Yep, okay. That's beautiful. So yes, so looking at the bottom one here, your zone of aeration. So it's your zone above your water table. The soil there is moist, but it has a lot of air mixed in with the porous spaces. Where's the air come from that's all mixed in there? Where do you get the air from? This is the soil that's out there right now. The soil that you see, that you dig, that you plant in.
Roots.
Roots are one thing that make air in the soil. They press the soil around. Yep. What do you think, James? Wind can do it because it can move it around, absolutely. Oh, Piper?
The small animals like frogs and ones that bury into it, also like worms.
Worms is a great one. Did you have one, Caitlin?
That's why.
You were gonna say worms too? Yeah, and also just by nature of the fact that soil forms from the detritus, the humus on top forms from detritus that fall, like all those leaves are gonna become soil eventually, right? And as they're falling, there's little bits of air in between them and whatnot. So that's a perfect example. Look at the fall. So yes, you're gonna keep some air in that top layer. That's your zone of aeration. And then you have your water table, and that's the spot where you go from the soil that you plant in and work with and whatnot to the soil that is always filled with water in the porous spaces. Now we'll talk about aquifers in a minute, and that's when you have like a patch of water underground. But your soil in the saturated zone is going to have water in between all those pore spaces. So that means like if you dig down in it and you pull a chunk of dirt out, the hole will fill with water. Okay, you know what I mean? So the water table here in a place like Georgia, you got to dig pretty deep to hit water. Now where I'm from, Virginia Beach, you don't have to go very far. You can hit water pretty easily. And so my dad, my dad's a mechanic and he has his own shop and he has pits. So today, mostly what you see are lifts. If you drive your car into a shop and it needs repair that requires a lot of underneath work, they'll put your car in a hydraulic lift and bring it up in the air. My dad much prefers pits. So the way those work is it's a giant, like a rectangular hole that you dig down into the ground. It's got concrete sides. You walk down into it, you drive the car up on racks above your head and you work right here. It's right above you. It's really cool. But every shop he's ever had, which are 3 now, he's had to dig pits. And the problem with digging pits in Virginia Beach, as you can imagine, is they're gonna fill with water because the pits are actually deeper than the water table. So what he would have to do is rent a pump or buy a pump. I think he's probably bought several by now, and put the pump in there and it constantly pumps out the water. And it pumps and it pumps. And usually it's about 6 months of the water being pumped. And then on a regular basis, you go and you reseal the walls and you reseal the floor and it oozes in and you keep pumping. And this goes on and on for about 6 months until the pit is pretty reliable and dry.
Sure.
But that I've watched it happen 3 times and it's
We're pretty sure it's not gonna.
pretty sure it's not gonna cave in. They still occasionally get moisture in the bottom though. And now they're full of grease and stuff. So it's pretty grody. So yes, and then so that's the problem with the water table, hitting the water table when you're digging, is that below it is your zone of saturation, where it's just good and wet. So what is the tendency of a material to let water pass through it? What do we call that? Caitlin? Permeability, that's right. We call that permeability. So that's the tendency of water to go through something. Does anybody remember what cell membranes are as far as permeability? Do you remember, Piper? Or do you remember? Selectively permeable or semi-permeable. Yeah, selectively permeable, which means that they only let certain things through, not all things through. They're picky, right? All right, so what do you call these underground areas with permeable sediment through which water flows?
Aquifer?
There's your aquifers. Okay, so here's the thing about aquifers. An aquifer can be the size of like your yard, or it can be like half the size of a country. Like we have a giant aquifer here in the States that goes all through kind of the Midwest. Like it starts up in like Illinois or whatever, and it goes all the way down almost to the Gulf, and it's massive, right? And sometimes they are just, it's lots of loose sediment or whatever, and you've got water that moves through it pretty freely. And sometimes it's actual big cracks and rocks that just fill up like a little underground pool, which is really kind of neat. So impermeable underground areas which act as barriers to ground flow water are what?
Aquicludes.
Aquicludes, very good. So this is where you've got places where your water can't get through. So what do you think might cause an aquiclude, or what might form or compose an aquiclude? Yeah, something that's impermeable to water. So it's going to be a type of rock that's not going to let water ooze through it. Now, some rock is somewhat permeable. It'll let water ooze on through, right? And then other rock is not. And that's the kind of thing that would be in this place, like quartz, for example. If you had a gigantic block of quartz, water's not going to ooze through it. But if you had limestone, it would start to dissolve and it could ooze through, right? So then what do you think this one is? It depends on the slope of the water table and the permeability of the material. Do you know?
Flow velocity?
Flow velocity, very good. All right. So yes, your flow velocity, this is going to depend on the slope of the water table and the permeability of the material. So basically, how quickly does water flow through the aquifer? Or does it just sit there? Generally, it's moving to some degree because Earth's moving and gravity's working on it. But some places it's gonna move pretty quickly, like almost like a little underground river, and other places it's gonna just barely move at all. So let's talk about springs now that we've had this whole lesson on hot springs and all the weird things. By the way, when we talked about FDR having polio, why don't we see polio now? When?
Because there was a vaccine that
Mhm.
pretty much everyone's gotten.
Yep.
As a small child to eradicate.
Yep. Do you know who invented that vaccine? Anybody know his name? Jonas Salk. So Jonas Salk did the polio vaccine. It was a very big deal. And most people, I would say over 65, have a scar. Probably ask your grandparents. Your grandparents will have it. On one of their arms, it's a round scar because the way they did the polio injections, for whatever reason, is they did it with like an air gun kind of a thing. And it left this round, it's about the size of a quarter on most people. And it's like a little, almost like a little pit on their arms. You can ask your grandparents, they'll show you. So they all have it because they all got that vaccine when they were little. When you guys were little, there were, I think the only option for your age group was IVP, which was the intramuscular. So they just give you a shot. There were a couple years where they did OVP, where they were giving it like drops in the mouth. That was oral polio vaccine. But for the most part, you guys all had it as babies. Now you can still find polio in places in the world, but usually, yeah, it's almost eradicated. One of the problems with polio is it get paralyzes parts of your body, right? But one of the things that can paralyze or partially paralyze is your diaphragm, right? So if you've ever heard of an iron lung, I know we talked about it last year in class in biology, and we talked, I think it was when we were on diseases, wasn't it? We talked about polio. Yeah. There are a few iron lungs left, at least in the US, that still function because there are some polio survivors left. They're very, very old. But the iron lung is like, it's this big tube, a metal tube. It looks really medieval and frightening, okay? And you get in it, and the only thing that sticks out is your head. There's like this collar that seals in around your head. And the machine like will reduce and increase pressure in the area around your body, which causes your lungs to fill up and, you know, contract and poof, 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 right? But they used to have polio wards in hospitals full of children inside those machines. And that's how if you want to look up some very scary pictures of old medical practices, it was necessary and it was the best they could do, but we look at it by today's standards and it's like, what were you gonna say? Have you seen it? Yeah.
Oh my gosh.
Whole polio wards full
Saw
of
all the way
people,
back.
children, a lot of them were children. Yeah.
FDR.
Yeah, so springs. So you have the emergence of natural discharges of groundwater, and we call them what? Springs. Very good. And they can range from a trickle to a river. Anybody ever seen a spring? Seen one for real? Yeah, seen water coming out of the rock or water coming out of the ground?
Very springy.
Yeah, they're
Indeed.
springy. So some of them rush out and some of them just trickle out, but that's a spring. And then the temperature of springs can vary, obviously. We talked about that. So the temperature of a spring is going to be most similar to what? What do you suppose? How do you suppose you're going to guess what it is? Do you want to guess?
The average like temperature of the ground.
That's pretty good. Yeah. So it's basically the actual the annual temperature in the region. You can find that annual temperature in the region and usually guess about the temperature of a spring. But that's obviously not going to be the case every time, especially if you have like a really hot one. You ever seen the pictures of the monkeys in the hot springs?
Yeah.
Yeah, I think it's in Asia. There's like, it's snow everywhere and there's a hot spring and these monkeys are chilling in it. I have I forget what kind of monkeys they are, but they're really cute.
Yeah.
Yeah.
And there was a video like of them in the water.
Yeah, there's some really great memes made with their faces too, because some of them look like so relaxed. And actually, a friend of ours went to Iceland recently, and he got in a hot spring in Iceland where it was snowing outside. And they've taken the hot spring and they've kind of commercialized it and built some walls around it and a little door and whatever. But it's cool. So hot springs, they emerge from deep aquifers, and they're heated. And how are these aquifers heated? What's the term? Do you know? That's it, James. Geothermally heated. So that's how they get warm. That's the name of the process, is geothermal. Break that down for me, somebody. Geothermal. Lee, oh no, Drew.
Geo means earth and thermal means like hot
Yes.
/ temperature.
Yes, geothermal. There you go. So heat or temperature coming from the earth, right? So hot springs are heated. These type of hot springs here are going to be heated to a boiling point. You're going to get pressure, vapor, and then it's going to erupt. And they're near volcanic areas, Parker. Geysers. Yes, very close. Geysers are old men. Geysers are sorry. Geysers are old men. Geysers are water. I know quite a couple geezers. Anybody else know geezers? I've probably called my daddy a geezer these days. Or even my father-in-law. He was a little geezerish this last visit. So yeah, so geezers. All right. So by the way, I shared to the parents Facebook group for this class. I shared them the link, but the video, that video that Jason made with all the planes and stuff, that's been put on YouTube now because they had their meeting last week. They had their reunion. And I begged my father-in-law because it was at Margaritaville and they had my mother-in-law's like, oh, they even have a volleyball net on the beach. And I was like, stop this. Lee, you have to go out there, no shirt, and play basketball like Top Gun. And he's like, well, only the other Top Gun grads qualified to do that with me, and they're all dead except one guy. And I'm like, so do it. He's like, nobody wants to see an old man out there with no shirt playing volleyball. I'm like, yes, they do. The whole internet wants to see that. Please do it. And he didn't do it. So disappointed. Because he's also like the most serious human being on the planet. Like, I mean, can you imagine when he ever, granddad? No. He's very serious. Yeah, but it would have been.
I want to see that.
It would have been amazing. These are real Top Gun pilots playing volleyball on the beach. It would have been awesome. So here's a little video about this particular.
Yellowstone Park.
Yep, I was gonna say this is Yellowstone, and we still have a little bit of the lag. It kind of pops every so often, so just keep focused, and you won't miss anything. Hang on.
There are more than 300 geysers at the park. The most famous.
A lot more geysers, too.
Hey, how's it going? Park geologist Hank Kessler is an expert.
There's
I
one.
don't think he's a geezer
There's a
yet.
geezer.
But he's
Uh-huh.
pretty geezer, I'd say.
One common for people to come
Yeah.
to Yellowstone ask, where's the volcano? Because many people think of a volcano with very steep sides and then a crater in the center. And the Yellowstone volcano is a very different type of volcano.
At 55 miles long and 90 miles long, this super volcano is underground. That's more than 1,100 square miles of magma.
Listen, so you don't say the same thing.
The Earth's surface. There have been 3 massive eruptions in the past 2 million years. Another massive eruption could wipe out parts of the United States and permanently change the Earth's climate. But Hank says he's not worried.
So we don't know as scientists whether there will ever be another super eruption of the Yellowstone volcano. But the eruptions that are more likely to occur would be much more localized and will not be something that would affect the entire world.
So we should be safe for the time being, at least our couple days here in Yellowstone.
Well, a couple days, I have no death wish, and I have no plans to leave.
The incredible heat and pressure of the supervolcano powers 4 different types of geothermal features in the park: geysers, hot springs, mud pots, and steam. One of the first things you notice at Upper Geyser Basin is a certain perfume to the air.
You left rotten eggs in your pocket again, didn't you?
Woo!
So when you're around in town, it smells
Come by.
It's actually volcanic gases, one of them being sulfur. You can smell it for miles. Call me crazy, but when I smell rotten eggs, I think of Yellowstone. Oh, man. When rainwater seeps through the ground and reaches the hot volcanic rocks below the surface, it begins to boil. Superheated water wants to expand. And so that pressure forces the water back up to the surface. It's kind of cool. You can see the smaller one that's just bubbling and just churning up all of this steam.
Oh, yeah. Somebody just cranked up the jets on the old hot tub.
You can see all the scat and everything around that. It's everywhere. This is Gallup Spring. Bison will congregate around the spring to stay warm during the harsh winters, but sometimes they get too close. One of the more deadly guys that they have here in Yellowstone. See how it's like dug into the ground? Animals get too close, they break through the snow and the ice, and not a good result. The Grand Prismatic Spring in the Midway Geyser Basin is the largest hot spring in the US and arguably the most awesome. The colorful rings surrounding this massive spring are caused by bacteria that thrive on the rich minerals in the pool. The center is too hot to support life, but the edges are cooler and downright intense. Look at that, dude. You've got red, yellow, orange, green, and blue. That is unbelievable. It's a pretty looking bacteria, I gotta say. Old Faithful is one of the park's biggest geysers, and it erupts 130 feet into the air on average. Hundreds of people gather around it every 45 to 90 minutes to watch the show. We're gonna try to see Old Faithful from the top at Observation Point. The half-mile hike will give us a panoramic view, 250 feet above the base. Old Faithful, new view. So, we've got about 10 minutes till Old Faithful goes up. 10 minutes? We should probably run. Everybody, they said walking. They don't even think the fact where we found out that the arms and they subscribe to the channel. There's a lot more to do.
As students are excited, excited, excited.
That looks like crap.
I'm not running up the hill. So, has anybody been to Yellowstone? Anybody ever been?
Nope.
I've never been, but I definitely want to go.
Yeah.
Yeah, it's definitely a bucket list for me. So is Warm Springs, Georgia. I want to go check out the little White House.
It's really cool.
Yeah, you've been. I really want to go see that. That's really neat. Mhm. It said there were, I think Piper said it was one of 3 presidential. So where would the other 2 be?
Jimmy Carter's, I'm sure one.
Jimmy Carter's one. And then where do we think the other? So you've got Little White House, got Jimmy Carter's house.
That's Theodore Roosevelt's one.
Why don't y'all see if you can find that out for me next week, or tell me, or send me an email. I'm curious what you find. And then you said it was one of 2 hatcheries. Is that what you said?
One of 2 national fish hatcheries.
National fish hatcheries. I know we have a hatchery right up the river, but I don't know if it's national or not. It might be because it's on the Hooch, and the Hooch is Army Corps of Engineers, so could be. So groundwater, weathering and deposition. Again, with the weathering and deposition, are we ever going to be done with weathering and deposition?
No.
All right, so here's what you have. When you have carbon dioxide in the atmosphere and it combines with water, it produces this very, very mild acid, which is what, James? Oh, what is it?
Woodrow Wilson.
Ah, Woodrow Wilson. Okay, very cool. I did not know that. That's neat. Caitlin, you have my answer? Carbonic acid. All right, so carbonic acid is what forms? It's a very, very mild acid, okay? So people in my junior class were like, whoa, if there's acid in this water, in the springs, then how are people getting in it? I'm like, it is very mild acid. Like, it's not gonna, there's acid in Coke, right? There's carbolic acid in Coca-Cola, So, I mean, there's lots of acid in lots of things, but it's enough of an acid to dissolve the limestone. So if you look there, if you've done chemistry before, you may know this chemical equation, but you have CO2 plus H2O yields H2CO3. So carbon dioxide plus water yields carbonic acid. Remember that. What you need to remember is not the chemical formula necessarily, or the equation necessarily, but that when water comes through the air, it picks up carbon dioxide and it produces carbonic acid, or at least remember that it produces a mild acid. Because when people talk about acid rain, this can be one of the components. And that's because the whole idea of putting too much carbon dioxide into the air, this greenhouse gases, right? You can make it more acidic is the concern, or that would pick up other things that would make it acidic. So when you look back down, then you get the carbonic acid, and it breaks down into hydrogen ions. That's your H plus. What do you know about it if it says H plus? What does that mean? Who can tell me what that means? What does it mean?
It has a positive charge.
It has a positive charge. How did it get? What does that mean as far as its structure is concerned? Do you know, James? No, or protons. Who knows? Come on, some of you did chemistry with me. How did it get a positive charge?
That was like 2 years.
It lost electrons. If it loses an electron, okay, it's gonna have a positive charge because electrons are negative. If it gains an electron, it's gonna have a negative charge. And if you look right there at those two, one has a negative charge and one has a positive charge, and that's because they came from a neutral molecule.
One has a positive,
Positive, yes. So where's your cation?
it would be in the CH.
Your cation CH3, right? It's just positive. All right, so, and the other one, it's a whole compound, so it's not cation. So what do you get here? What's happening there? What you're getting is, this is the dissolution by groundwater. So this is when groundwater that is now full of the carbonic acid, it doesn't stay carbonic acid forever. It falls apart, okay? And then what it ends up happening is you get some of those hydrogen ions, these guys right here, and then calcite, and you're gonna end up with calcium ions and bicarbonate ions. So there's a lot of chemical reactions that are going on under the ground where the water has soaked in over time. And that forms caves. All right, so what do we call underground caverns with openings at crust? Oh, Jack, caves. These are caves. All right. And karst topography. This is what we call an overall area where you've got a lot of groundwater that has been dissolving the limestone below, and you end up with sinkholes and caves. And what's it named after? Do you know, Liam?
A region in Croatia.
Yeah, a region in Croatia that has a lot of these features, which is, I think, called karst is the region. So now they just call it karst topography kind of everywhere.
That happened in Croatia.
Yeah. It's just, oh, in Croatia? I have a friend who's Bosnian and they have kind of issues. But Croatia is gorgeous. I've seen pictures of Croatia that are just to die for. I would love to visit Croatia, or this one is older. I feel better about this. The last one I looked at that I said looked old was 1997. I was like, I was still in college. It's not that old. But this one's 1954. So that one's old. So they call it karst topography. Now we have some caves here in Georgia, and we have one. Actually, I meant to put a picture of it, but I'll find it for you after class. Don't let me forget. It's called Ellison's Pit or Elliman's Pit. Anyway, we do have some caves in Georgia, obviously, but this one that I want to show you is pretty crazy. It's almost like a sinkhole meets a cave, and it has some records as far as size. I may have shown it to you all before, I'm not sure, but it's pretty awesome. So groundwater deposits. Okay, so what happens underneath the ground? Groundwater is now going to make deposits because it's got
Tornado.
tornado. But it's got things in it that can precipitate out. It's got molecules in it that can precipitate out. So you've dissolved the rock, but now all the components that have dissolved the rock are going to evaporate or flow away, and you're going to get some of those chemicals that created the rock. They're going to come back together and precipitate out. So what do I want for that first one, Piper?
Stalactites.
Stalactites is what I want for the one that says hang tight. You're right. And Liam?
Dripstone.
Dripstone. Okay. Where's dripstone going to go?
On the top.
On the top. Okay. And Jack? Stalagmites. That's right. And where's that going to go?
In the middle, one with the mound on the eighth.
In the middle. Okay. And what's the one at the very bottom? Anybody know what it's called when you have a stalactite and a stalagmite and they touch? A stalag. What is it, Piper?
A pillar.
A pillar or a column. Yeah, you're right. Okay. So what we have is, this is where you were looking for dripstones, right? And you got it right. So you got dripstones. There we go. So dripstones are when water drips from the ceiling of a cave. Have you ever been in a cave and seen that happening? Ever been on a cave tour anywhere? Seen that? It's pretty cool. It'll drip, drip, drip forever. So you have to think about it. You've got water and it's groundwater and it has dissolved chemicals in it. Some of those compounds in it can precipitate out or can evaporate. It's more like evaporates. Do you remember when we had the salt and we put it on put it under the microscope after the water had evaporated, and we saw not just the salt, but we had the what did we have? We had copper acetate monohydrate, and it made those beautiful blue crystals. Same thing, but it's got gravity acting on it at the same time, so it's dripping down, and little bits, like one molecule at a time, are starting to cling together, and over time, it's going to form a stalactite. On the bottom, you've got it dripping down and it'll start to pile up. If you've ever done that with sand, anybody ever take like really wet sand and pour it between your fingers like this and it builds like its own little stalagmite? Yeah. My uncle used to make entire castles. He called them drizzle castles, but he used to make these incredibly elaborate castles out of just sand drizzle on the beach because he had nothing else to do all day. And that's what he did. If he wasn't body surfing and coming home with his chest bleeding from the sand, that's what he was doing. So he was my mom's he's my mom's youngest brother, so he's fun. He's fun uncle. So yeah. The funkle, yep, funkle, yep. So stalactites hang tight like icicles. Stalagmites come up from the mound on the cave floor, and we've talked about how to remember these before, right? And then you got columns come together. Remember this one, right? Remember, how do you know it's a stalactite? How do you remember it? Because it does what, Drew? It hangs tight from the ceiling.
And it's a stalagmite because you might impale yourself.
You might impale yourself on it or sit on it or
You might die.
you might die. Yeah. It might reach the ceiling if it keeps growing, but if it does,
A column, if you don't do that thing one, you might smack into
you
it.
might smack into the column. So the thing about columns is that it's pretty obvious. Like they come showing together, you have a column. Like that's not one you have to worry about too much, right? So hard water. So hard water is something you get in areas that have a lot of limestone from where their water is sourced. And that's because it still has some of these solids dissolved in the water. You ever seen the old commercials? If you watch the old Flex Seal commercials, they probably will like bleed you into a YouTube rabbit hole.
That's top.
Yep.
tier.
And you'll end up in the old CLR. You ever seen the original CLR commercials where like they put CLR? CLR is now everything. Like I have a spray upstairs. It's a great CLR spray. But CLR, they used to be a paste, and they would do cool stuff. Like they'd have this bowl of grape juice and soda, and they put like one little drop and it would go clear. And then they pour mud on a carpet, they scrub it and it would gone. But one of the things that CLR actually does really, really well is it dissolves hard water deposits. So hard water deposits are really like a thin sheet of limestone building up in your shower, which you don't want, right? So, and if you've ever, like our water here isn't super hard. Most water is, soft water is the exact opposite, right? And soft water can be so soft, so without other chemicals, it's really hard to get like even the shampoo out of your hair. You'll be there for like a year trying to get the shampoo out of your hair because it doesn't come out. So it's, especially if you have hair like mine that comes on the hair. So you want your water to have some chemicals in it. And they're going to be, and we'll talk about it in a minute, but they're going to be limits to all the different kinds of chemicals. But if you've got hard water here, which is what we're talking about, there's not really anything there. It can cause buildup. And a lot of places where you see it is like around the shower head. You can see it there. It'll build this white, almost like a white crust. And then you'll see it around the drain. And then the walls of the shower will get like this white dusty look. It's not very pretty, hard water, if it leaves deposits behind. So if you live in an area where there's a lot of limestone and they're sourcing your water from the ground, this could be an issue you have. Where's our water source from here? Lake Lanier. So it's not sourced from the ground. So we don't really have this problem too much. But if you live in the middle of the country where there's no lake nearby and your water's coming from an aquifer in a nice big patch of limestone, that's what you can get. It can be very hard water. Now this is the coolest cave I've ever seen. This isn't the big one I was talking about.
Mammoth Cave?
It's not Mammoth Cave. Mammoth Cave is the longest cave.
I've been there. It's really
This is, my cousin did a whole, I'll tell you, but this is one of the biggest caves. I think it is the biggest cave. It's in Vietnam. And it was somewhat recently, James is like, yeah, it was somewhat recently discovered, which is the crazy thing. It's somewhat recent that, at least in recent history, that it's been discussed, whatever, studied. And some of the pictures of it are amazing because it's so huge. Mammoth Cave, which is in Kentucky, which is our longest cave. My cousin did a park ranger camp there when we were in high school, and she went for, I think it was like 3 weeks or something, but they told her she could only bring 5 pairs of underwear. And it freaked her out because they said, wear one pair for 3 days and then turn it inside out and wear it again. She's like, nope. She went to Walmart or Belo or something, bought the cheapest underwear she could and buried it in the woods. She's like, I am not doing that. She's just like, nope, I'm not doing that.
This is almost completely unrelated.
Almost, but not quite.
It has to do with caves still.
Okay, what?
So there's this footage of elephants
Uh-huh.
in a cave.
Oh,
And
Africa. There's like 4 stones.
Oh, wow.
And they're in this cave
Mm-hmm.
and they're using their tusks to mine salt
Oh, that's
to
cool.
lick up and like supplement.
That's very cool. You can put salt licks out to attract deer and stuff too. What do you want to say?
I've also been to a cave in Tennessee, which is like a tourist attraction called the Lost Sea. But like you go down there and there's literally
I want to go there.
a
I was-
lake under the water.
Yep.
with, like a bunch of albino
Right.
fish and stuff.
I've seen that on the road. I've passed by it and I really want to go because there's a whole like little like village right under there, like a
Yeah.
little lake, and
Me and my grandma went and
Uh-huh.
like me and everything on our way home from a road trip. And it
that's
was
super cool.
They just shut off all the lights.
Oh, yeah. So this is this cave in Vietnam, and this might have to be a bucket list too, because it's amazing.
Deep within the Vietnamese jungle province of Cam
Vietnam.
lies a secret wonder of the world. That is until 1991, when a local logger named Ho Khan made a spectacular discovery. While searching for agarwood alone in the forest, he became lost, but soon stumbled upon a massive rift in the limestone mountainside. Out from the opening came billowing clouds, the roar of rushing water could be heard, and a strong and constant gust of wind blew out from between the rocks. For fear of the unknown, Ho Khan explored no deeper than the entrance to this cave. 15 years go by until in 2006, Ho Khan speaks with 2 members of the British Cave Research Association, Howard and Deb Limbert, who traveled to Vietnam to discover new caves. Intrigued by Ho Khan's description, they seek him out and urge him to lead them to it. But after many failed attempts, Ho Khan could not rediscover what he had found by mistake all those years ago. It's not until 2009 that by pure chance, Ho Khan finds himself back at the entrance of this cave while on another hunt for wood. This time, he made sure to remember its exact location and contacted the Limberts immediately. They returned to Vietnam as fast as possible, and together with Ho Khan and a team of other explorers, they take man's first steps into the massive cavern in the mountains. It's uncovered that the cave runs 9 kilometers deep into the earth, with some parts reaching 200 meters high and 150 meters wide, large enough to fly a Boeing 747 inside. These dimensions made Ho Khan's discovery the largest cave on Earth by volume, coming in at over twice the size of the next largest cave. In total, there's around 38.5 million cubic meters of empty space within this cave. That's nearly the same amount of space as the Grand Canyon, all hollowed out beneath the Annamite Mountains. But this isn't the Grand Canyon. This is Ham Song Dong. Translating very roughly into English, the name comes out as Cave of the Mountain River. This name comes from the fact that a stream of water pours out from the entrance of the cave, a river seemingly coming from within the mountain itself. Miles deep into the cave, jungles can be found inside its 2 dough lines, which are basically breaks in the roof of the cave caused by sinkholes, allowing sunlight to shine deep inside the earth.
That is
Exploring deeper inside this cave, you can find stalagmites that measure up to 80 meters tall, some of the tallest ever discovered. Even deeper, and you can discover large cave pearls, some the size of baseballs, and occurrence so rare that you probably didn't even know cave pearls were a thing. Knowing all this, I think it's safe to say Hang Song Doong is not only a spectacular cave, but also one of the most impressive sites on the planet. But how exactly do caves like this form in the first place? Well, to understand this process, we actually need to start in the ocean. You see, sea creatures like crabs and corals, as well as tons of microscopic organisms, use the minerals dissolved in the ocean water to build their shells. When they die, their shells are left empty and fall over the ocean floor. Once it happens more time, the shells will begin to build up into a layer. Over time, this layer of shells gets buried and buried and buried until it's under so much pressure that it becomes a single solid rock. We call this rock limestone. You've probably heard about it before, and you've definitely seen it. It's a grayish-white rock found in many cliffs and mountains. Then, depending on plate tectonics, this limestone might get pushed above the sea, and that's how we get limestone on dry land and in mountains. If you're curious, this is what limestone looks like under a microscope. You can still see some of the skeletons of long dead sea creatures.
Wow.
Cool, right? Okay, so next we need to know what limestone is. Just a few seconds ago, I explained that sea creatures take minerals from the oceans to build their shells, and the primary material they do this with is called calcium carbonate. This is a really good building material because it's strong and it's readily available in the ocean and can dissolve easily in ocean water, so the materials get recycled and used by new organisms. That's important, remember that. Limestone dissolves easily. Lastly, you want to know how the thermal interacts with the atmosphere and the soil. Yeah, that'll probably make sense in just a second.
So we all know how rain is made, but for anyone who missed that day in school, water from the earth evaporates and maybe some water from trees evapotranspirates. Then that water collects in floating materials with low pressures and low temperatures and condenses to become clouds. If this moist air becomes too saturated with water, some of it will precipitate out and fall to the earth. That's what rain is. But before that happens, while still in the clouds, the water molecules interact with the gases in the atmosphere. Some of the water will come in contact with carbon dioxide, and sometimes when they crash together, then the slightly acidic rain falls to the earth and travels through the soil, it can pick up even more acids on the way down. Eventually, this acidic water sinks to the water table and becomes part of the groundwater. If this happens where there's a layer of limestone in the soil, this slightly acidic groundwater can eat away and dissolve it until a cavity in the earth is created. Because, again, limestone dissolves easily, even in weak acids. This process can actually be remarkably fast in geologic terms. Hang Song-Dun, for example, is only roughly 3 million years old. That's younger than the famous Australopithecus fossil and human ancestor Lucy, which is 3.2 million years old. Then, fissures, imperfections, and sinkholes can create entrances to these hollow tubes beneath the ground. And when they do, you have a cave. If the limestone is on the surface, it can instead be carved into cliffs and other strange and unique shapes. This type of landscape is called karst topography, and the more rainfall an area gets, the more karst topography can form, and the greater number of caves and sinkholes there will likely be. That's why Howard and Deb Lindbergh were in rainy Vietnam looking for caves in the first place, and that's also why it's no surprise that Hang Song-Dun is where it is, one of the wettest regions in the world. Now here's a rough map of where karst topography is to be found on Earth. You can see one of the biggest regions of karst topography is here in southeastern Asia, right where Hang Song-Dun is to be found. In this area, you'll also find other strange karst formations like these famous mountains in China. Then, over here in the United States, it's perhaps the second biggest patch of karst features, and it's in this area that you'll find more famous caves like Mammoth Cave in Kentucky, which is the longest cave on Earth, at over 650 kilometers long. But let's go back to how caves form. Depending on the size and shape of the limestone layer, a few different types of caves can be created. But almost always, a cave will have an entrance point where water can seep in, called a swallow, and a point where the water empties out, the spring. In the case of Hang Song-Dun, the spring is actually what we consider as the entrance, and the swallows would be the two holes in the cave ceiling caused by sinkholes. And that's essentially it. There are two things I should know before ending, however. First, while limestone is the most common rock type for caves to form in, any rock that dissolves in weak acid will form caves over time. So deposits of rocks like dolomite, gypsum, and even marble can become caves given enough time. But limestone is by far the most common. Second, this is how solution caves are made, and there are actually a few more types of caves, and each one forms in a different way. But solution caves are the most regularly occurring cave type, so I figured that would be the focus of this video. If you want to see another video on how any of the more rare cave types form, maybe give this video a like and subscribe. Oh, and I have a Twitter now, so if anyone is interested in getting updates when videos come out and such, here's my blog.
I want to go, right? You see the picture with the tents in it? Like there were multiple tents on a beach inside of a cave. That was amazing.
That picture with the rainforest reminds me of those
Mm.
movies that are like Jurassic and stuff. It's like,
Note that he said,
On the side of the cave.
note that he said it was how solution caves were formed, right? So if you were to see,
Imagine just like walking through.
if you were to see anything on a test about how caves were formed, it would be solution caves that I would be looking for as the answer, because that's really the only type we've talked about in class, you know, just in case. So, no, just in case. So let's talk about wells. So what's a tunnel that's drilled past the water table? The water can come up through.
well,
Well,
Wells, I'll give it a joke. Wells is a tunnel. Okay, now,
my yard.
we got, you have one in your yard?
Yes.
You do? Awesome. What now?
Old one.
An old one. Oh yeah, you do in the front yard, isn't it?
Yep.
Yes, I've seen it. It's cool. Does it work? Or is it ornamental?
We hear like, okay, so we do like.
I
there's
love
some-
it.
There's some experimenting. So
Uh-huh.
we like drop one in there.
drop
And-
a child in it.
No, because it is far down. But
Yeah,
we did
sure.
hear like a splash of water.
Okay, so it may be maybe dried up or it could be plugged up in there.
But
All
you
kinds of
definitely hear
possibilities.
some.
Yeah, uh-huh.
Child strong enough, go to a small enough but small enough child and lower them into the pit.
Our sister.
So in the, I want to say it was the late 1980s or maybe like 1990, 1991, there was a little girl in Texas who fell in a well. Yeah, they called, her name was Jessica McClure, and I remember it because it was on TV almost round the clock. It was right when like round the clock news came out.
Yeah.
But there was a well in their yard and it was like, guys, it was like an 8-inch round hole, like a tube pipe. And she was running and she was 18 months old or something, or 2 years old. She was little, 2, maybe, I don't think she was much older than 2. And she was running and she fell, but the way she fell is one leg went down and her other leg was up by her face. And so she went down like in the splits and she got stuck way down in the well. And what they had to do was they dug another tunnel and then came in sideways to get her. But it took, I want to say it was close to 2 days. And she was stuck in the well. And I remember there being a thing about how she was singing Winnie the Pooh to herself to try and keep herself calmed down. I mean, because it's dark, it's cold.
You're doing the
She,
splits for 2 days.
I think she lost part of her foot because it was up so high, it had no circulation for so long. Like she came out and she was all purple and it was terrible. Yeah, it was not good. Wait, Milo's talking. What now?
They should have just set it out on cold last.
There you go. Lassie would have fixed it because Lassie would have gone, Jessica's down the well. But it was a big thing. It was like a national news event. This kid fell down this well. So that's why you should always have caps on wells. Even if it's a well that's like the little traditional kind where you see a little round thing and a little roof on it, a little bucket. Like you should have a grate or something in there because you don't want anybody to go down it.
I was gonna guess like 80s because dangerous stuff.
Yeah, a lot. Oh yeah. Oh yeah.
She's like,
80s
I
was fun.
associate the 80s.
Yeah.
with dangerous thing.
Well, I lived through it, so that means I must be somewhat tough, I believe, because it was a big old deal.
No.
October 14th, 1987, when she went down, 18 months old, went down, and so
I
1987.
hear 87,
Yep.
86, and 88, like
Yeah.
the most.
It was scary.
She's still alive?
Yes, she's alive and she's got a family and she's
Do you think
moved
that would
on.
make her more flexible being in?
I think, but at that point, all of your tendons are doing what they're gonna do. So we've got 2 different kinds of wells too. So we'll go over that in a minute. So you've got the difference between the original water table level and the level of water of a pumped well. Do you know what that is? Okay, Milo's got it. Drawdown. Okay, so that's your drawdown. And then recharge. What's recharge? Caitlin? Yep, she got it. Come on, you got it.
The water supply of wells to be replenished.
Yeah,
Water from precipitation.
perfect. So when it rains, the water gets replenished in the well. And it may not rain even where you are. It may rain way north or south of you and the aquifer may flow your way. So if you've got a well and you dig it straight down in, you're trying to tap into an aquifer. If you don't have an aquifer to tap into, you may just be tapping into the saturation zone and you can get water in there, especially if you build some sort of filtration system around it. You'll get water that comes into your little hole that you've made, but you'll also get sediment and yuck. So what you want is the water off the top and not the settled stuff on the bottom, right? So so an ordinary well is the kind you think of where you've got water down there at the bottom and you have to go down and get the water and pull it up, either by a pump or a bucket or whatever. Child. An artesian well, what's an artesian well? What's the difference there?
Up to the surface.
Wait, yeah, okay, yes, it comes up to the surface. So it's under pressure. So the groundwater is under pressure and it comes up to the surface and it can spurt out. So it's like a spring, but it's being used as, it is a spring, but it's being used as a well. So that's an artesian well, it's under pressure. Whereas you'd have to go down and get water from the other ones. So what are some threats to our water supply? So overuse, obviously, that's a big deal.
It doesn't matter can't get destroyed, so.
This is true. All the water on Earth now is all the water that's ever been on Earth, except for like really weird things where people like separate water molecules by electrolysis and that's minor. But in general, all the water has always been here. So
the water we drink, dinosaurs probably.
it's possible. Absolutely. So as Drew is saying, it's all the water that's ever been here. So the problem is the water supply is the water supply, but it might not be near you. Maybe the water is somewhere else and you can't get it. So what's subsidence? Who's got subsidence? Liam, what you got?
The sinking of land.
The sinking of land, okay. So how does that happen, do you suppose?
The volume of water underground helps support the weight of the soil, sediment, and the rocks. When the height of the water table drops, the
Mhm.
weight of the material above is increasingly transferred to the aquifer's mineral grain,
Right.
and they squeeze together more tightly.
So if you've
And
got,
then it will sink.
yeah, if you've got a good aquifer underground and everything's good, and then, you know, one day you notice that the ground around you is sinking a bit, and you're like, oh, that could be a clue that you're running out of water and everything's squashing down into the space where the water previously was. Uh-huh.
Once again, when we were in Dolphin Island, my family, that fort, they had
Mhm.
like a rain system to catch rain
Yeah,
because
yeah.
for drinking water. But their basin little thing that they had underneath like the shooting towers leaked,
Oh,
so they put lead in it, of course.
yep, sure they did. Yep.
So basically,
Great idea.
they were poisoning themselves.
Yeah. Giving themselves neurological,
They just called
Issues,
it
yep.
coastal fever
because they didn't know.
because that's just what happened when people drank the rainwater
Yep.
that they filled with lead. It was
Yeah,
coastal fever.
not fun.
Weird.
What you gonna say, Caitlin?
Just so you know, it is not illegal to collect rainwater in Georgia.
There you go. It is illegal in some places, isn't it? Yep. Well, because people want the water to go where the water is gonna naturally go, so that the runoff can be predictable and the streams and whatever, but you know, a lot of people really want to, you know, collect their rainwater to use it for gardening or whatever. My next door neighbor at my old house had a big old barrel that he would collect all of his gutter water in. Yeah. What were you gonna say, Milo?
Do you want to collect rainwater?
I've seen people actually protest about similar things because it's one of those things that gets the government overreach. This is one of those things that the rainwater buckets is one of those like Hallmark libertarian complaints. Can't even collect rainwater.
In Illinois, it's not illegal to collect rainwater, but specifically in Chicago, it's illegal. In Chicago, I'm pretty sure you'll get fined for it.
Yikes, you'll get fined for
Yeah,
it. I'm not surprised.
That's the crime Chicago has to work.
Yeah.
In a photo, it was like a protest or something,
Mhm.
and someone was holding up a sign, and it said, "You guys are blocking the library."
I like it.
The protesters are all.
So some other concerns, some other threats to our water supply would be salt getting into the water. Now, Jack mentioned lead can cause poisoning. Radon coming from radium, which if you have basements, when the houses are constructed, very often they will do like a radium check in your basement. They want to make sure that you are not poisoning yourself that way.
Other things are also bad for your water supply.
Yes, lots of things can be
such
bad.
as uranium.
Facts.
So what that is there? Yeah, feces, all this fun stuff. Yes. So
Dead animals.
yeah, so your water, the government has set limits for how many particles, or actually it's usually parts per million of whatever chemical or particle can be in water, but they also have it for food. They also have like say you run an oat mill and you have a factory full of oats that you're going to turn into granola, or you're going to ship some off to
Oatmeal.
ship some off to Quaker to make oatmeal and ship some off to somebody else that makes cookies, whatever, but you got oats. And when you sell those oats, there is a limit on the number of like rat feces that can be in there, mammal hairs, like rat parts, body parts. I'm serious. Because if you think about it, it's impossible. It's impossible to say there's no rat toes in this silo of oats. It's not. So there's a limit. They set a limit.
Somebody in the FDA was paid.
Yep.
To write everything down.
Yep. Probably the same guy left a job at, you know, some safety department, and he was the guy who said not to dry your hair in the bathtub, that kind of thing. You know.
There's
Yeah.
also
So
What is such a depressing life?
yep. And what?
On Dolphin Island, there's this thing called.
You need to go to live on Dolphin Island.
It's recent and there's a lot of facts. 'Cause
Yeah.
They're on a science adventure.
Okay, yeah.
And there's a thing called Nutria. There's like. it's a little,
Nutria,
like-
yeah, they're giant rats.
Yeah. and they're
Terrifying.
invasive and whatever.
Yeah.
And they're going in dog food. So me and my
Huh?
friend's joke while we were there was you can't spell nutrition without nutria. And,
Yeah.
Yeah.
Nutria are kind of like real life ROUS, you know, rodents of unusual size. They're huge. They're like gigantic muskrats. Okay, so this is interesting. This is how scientists are harvesting fog to secure the world's water supply.
Excuse me?
Fog. Yeah, this is pretty cool.
Fog.
The global water supply
What the
faces
fuck?
Wait.
climate change, overconsumption, poor management. It is a challenge pushing scientists, politicians, and designers to hunt for innovations that could lead to new sources of water. John Yang reports on one such effort that involves innovation for our breakthrough series on the leading edge of science and technology.
Situated on the edge of the Sahara in southern Morocco, Mount Bout Mesguida gets only about 5 inches of rain a year. But what it lacks in rain, it makes up for in fog, which blankets the area for about half the year. So that's where residents have now turned for their water, harvesting it from fog.
That's
Alongside scientists from the German Water Foundation, the Moroccan nonprofit Dar Si Hamad has set up what's said to be the largest fog collection project in the world. About 19,000 square feet of nets called cloud fishers. As fog rolls through, the mesh traps fresh water, which drips into a receptacle. A network of pipes takes it to the villages below, where about 1,000 people every day use it for drinking and watering plants and animals. Jamila Bargash is director of Dar Si Hamad.
The fact of having water has radically transformed the life of the women who used to walk for hours to get water, one, and two, there was always the fear of not having enough water. Right now, that fear is not there anymore.
But in other places, the fear remains. Experts say there's a global water crisis, with at least 2/3 of the population living in areas that lack water 1 month a year or more. This summer, Chennai, India has had to rely on water deliveries from tanker trucks. A poor monsoon season left all the city's reservoirs dry.
The relationship between water supply on the one hand and water demand on the other.
Betsy Otto directs the World Resources Institute's Global Water Program.
We're seeing really significant shifts, much more erratic rainfall, snowpack and glaciers that have been very important sources of slow release water to much of the world are disappearing. So we're seeing really significant changes from global climate change.
While collecting water from fog may sound revolutionary, it's actually an ancient technique and one found in nature. An African beetle captures fog droplets with small bumps on its back. And archaeologists have found evidence it was used centuries ago in the Middle East and South America. How can we get as much water as possible from fog today? With climate change and high consumption making water scarcity a growing problem around the world, researchers are tackling that question. One technique is being tested here at this farm at Virginia Tech.
For fog harvesting.
Industrial design professor Brooke Kennedy is part of the team that
I'm married to a
developed
Hokie.
the fog harp. It uses tightly placed vertical wires as opposed to crisscrossing mesh.
Either they tend to be too open, so a lot of fog passes through them, or they're too tightly woven, and so the fog droplets get stuck. What we've done differently here is that we've removed the horizontal wires, and this prevents the water droplets from getting stuck, so they quickly, through gravity, drop away.
Tests have found this design to be at least 3 times more effective at capturing water than traditional nets. For Kennedy, this was a case of biologically inspired design, influenced in part at least by California redwoods. The towering trees draw much of their water from fog accumulating on their needles.
The solution isn't embedded with, circuits and other high-tech accoutrements or features. It's a fairly simple solution, but yet by just tweaking meaningfully the design, really at a small scale, the results are rather dramatic. What would their visual form be?
The team is now working on the next generation of fog harps, making them sturdier, more colorful, exploring the best wiring material. Vapor going through the string. Within a few years, the plan is to test hundreds of harps in places battling water scarcity like Peru or South Africa.
And we have a setup to capture water.
In Cambridge, Massachusetts, MIT scientists are trying to take the innovation surrounding fog collection even further.
Oh, mass.
They discovered that zapping air rich in fog with a beam of electrically charged particles draws the droplets toward the mesh, dramatically increasing its ability to collect water.
Right now, the system is off, so you can see that this plume can pass through the mesh unaffected and then it goes around. But when we turn the electric field on, the plume vanishes instantaneously and then water starts collecting on that mesh.
The idea is to use the system on power plant cooling towers. Almost 40% of all fresh water taken from US rivers, lakes, and reservoirs is set aside for that critical purpose. MIT mechanical engineering professor Kripa Varanasi leads the team.
We were able to fundamentally change the trajectories of these droplets. In fact, we saw, these drops that are going away make a U-turn and come back. And so we went from that half to a couple of percent efficiency to almost 100% efficiency.
While both the projects are promising, the expert, the scientist, and the designer agree water innovation must be coupled with better water management.
We're gonna have to find new ways of storing it or capturing it in places that used to have more water than they'll now have. Yes, it's important to have those technologies, but that alone is not enough.
Water is a very passionate topic coming from India, where water is a major crisis. It's a big societal problem and not a simple, you have a power plant, I can sell you this thing.
It's not going to be the only measure that needs to be taken. I think conservation in combination with other techniques working in unison will help us tackle water scarcity.
That combination may mean the difference between losing or maintaining one of the most basic elements of life on Earth. The PBS NewsHour, I'm John Yang.
People.
Yes,
people.
People listening for water. So this can be, we'll come to this in a minute. This can definitely be an issue in a lot of places, water scarcity. You know what a life straw is? Anybody have a life straw or seen a life straw? Yeah, it's a water bottle with a straw down in it, and the flip top spout on top that you can drink out of like a straw. But the straw is big and it's a filter. And the idea is you can take it from any stream, wherever there's contaminants, you can scoop it up, and the life straw does the filtering for you. And it would definitely do filtering of sediments. I'm not sure that it's successful at filtering things like, amoebas and, some of them might be, yeah. But part of their thing was, when you buy a life straw, we'll give one to somebody in a place that isn't water. They're, water insecure, which is the thing now, food insecure, water insecure, home insecure. So they'll do that. And there are lots of solutions. Both Cole and my husband went on a mission trip several years ago to the Navajo Nation in New Mexico, and the water there was delivered by a water truck. And they had to follow the water truck and then help give out the water. Like it was a giant tank on a truck that went up these hills and into the desert and filled these water tanks for people. And that would be their water for the week. So they'd have to manage that for the week. And if you remember, when we had a couple of years back, you guys were little. Does anybody remember the big 100-year drought at Lake Lanier? It was several years ago. You guys are tiny, but it was to the point where you could walk out onto the lake bottom in a lot of places. Yeah, it was wild.
There's so many shells and stuff.
Yeah, and we were under a severe water restriction. Like we weren't allowed to water our lawns and all this other business. And we've had that issue before too, not just it's worse when there's a drought, but part of the reason they restrict water usage up here, even though there's a whole lake, is because there are some rare mussels that live in Alabama on the other end of the Chattahoochee, and they want to keep their water supply for these rare mussels. What are you gonna say, Liam?
So I'm actually on the way to my hockey rink. There's this little pond that's drying up.
Yeah.
Was like up here and now it's like down here.
When that 100-year drought hit, there used to be a house on Old Atlanta Road that had a beautiful pond in the back. And it's over off, if Old Atlanta Road has that big hill that goes up and down, if you've been on it, it's over there in that area. And it had a beautiful pond in the backyard. Pond was probably as big as this whole living area, maybe a little bigger. And it dried up during the 100-year drought and it never refilled. There's now like a bunch of scrub trees in there. I can't imagine having lived in a house for 20 years and having a pond and then one day it's gone. So one more quick thing, go ahead.
And in my grandma's neighborhood, the house right down the hill for them
Mm.
is built on a floodplain. So they have like 3-4 ponds that's built for like the 100-year flood.
Yep.
So like if it floods, it only goes up to like their doorstep. It doesn't go any higher.
Yeah, that's necessary to construct stuff like that. Yeah, there's a leaf stuck on a Joros. There's a Joro spider. Thank you, invasive species. Got a leaf stuck. So these are the topics for your test.
I'm using the force to hold.
Okay, yeah. These are the topics for your test. I am gonna put this out for you guys. Where do you find this if you want to study this? Where do you find this? Dropbox in the resources file. Yep, the student resources file. There's the whole thing that says test. Oh, there it is. And then there's also all the videos we've watched, and there's some videos that maybe the juniors have seen that you haven't seen. So sometimes you can scroll through them and go, oh, this might help me. These are the topics. I left this very broad. Okay, I'm not getting, this is not as anywhere near as specific. I'm going to be showing you pictures of things and asking you to tell me what it is and how it got that way. Can you recognize it? What caused this feature? How did this feature get here? Okay, so these are gonna be a little more thinky questions. You got to thinky. So that's that. And then your binder work, I will you can find that with this slideshow because I still have to, they're right here. I haven't filled it out yet on here. So I'll put that with the slideshow in your folder for your lesson in Dropbox too, if you're looking for it. Does anybody have any questions about the upcoming test or anything else? Yeah.
When is it due?
The test is due next Tuesday, 8 a.m. So before you leave, I told you I was going to show you this. I need to show you this Ellison's Cave because I don't think I put it in any of the. This thing gets in the way and it makes me nutty. It's like, go. So Ellison's Cave is in Walker County, Georgia. And just a picture of it. Oh, I didn't mean to tap you. There you go. Unbelievable, this thing. So this is the pit. Remember I told you it had a pit? This is what I meant by the pit. Do you see this, guys? Those are human beings coming down a little rappel line.
Yes, jump out to kind of long it takes for them to
into this pit. It is super deep. This is the bottom of it. Hold up a sec. Wait a sec. This is the bottom. And there's a really great picture somewhere where you can see them all coming down in a line like it's taken from further away. The entrance, that's cool. There's water down at the bottom. Yeah. The entrance is boring and looks like that. You would never guess that it's anything big. But it has, the Wikipedia page will tell you, it is the 12th deepest cave in the world. It's 12 miles long, extends 1,063 feet vertically. And the two pits, they are the two deepest pits in the contiguous US. The Fantastic Pit, which is the one that was just a picture of, is 586 feet, and the Incredible Pit is 440 feet. And then the nearby is another one called Smoky that's 500 feet, and Smoky 2 that's 262. That's a lot. Get your coins. Be sure you've got your Q2 packet.
I forget.
And I will see y'all next week. James, we're gonna be
Man, I got a lot of money.
for
Piper, do you wanna get
to check it out.
Yes,
So when
I
I
do.
talked to Kevin, he said, that,
so much.
might be touching on the roots, but he's not really sure what he's gonna do. He thinks he might put optionals on Fridays. So we're just gonna get a feel for it. I mean, we're still happy at the bio station, but we know that that's where it means that I'm jealous that you're doing it. It's just one of my favorite games. You will love it. Yeah, you know. Never done it. You will love that, man. Yes. Yeah, we're gonna go this afternoon. We're gonna go there.
Well, I'm saying like my practice.
Yeah, you can go to practice.
I don't want to.
Well, yeah.
Well, I just want to go to the gym.
Well, you can come and maybe work out a little bit. And then tomorrow we are going to Cobb for the judge, right? Tyler. Yeah. Okay. She here. Are you all right? Why are you hanging out there?
Look at the tail. Look at the boy. Look at the hair. Three, well, almost three. Let me do next. Yeah, now I'm getting bigger, and I got pictures of him next to my in-law, but here's Freddie. And it's so funny because he looks so tiny compared to Freddie. And my mother-in-law loved the picture of you with Freddie. I got a picture of you on the couch with Freddie during class.
Yep. My mother-in-law loved it. She's like, oh, he's getting good and spoiled. Yeah.
Have Alex to get these two today.
Ah, yes, this is true.
He wants my coins.
He wants my coins. You don't want your coins?
I got Jack's coins, so it's gonna take me off.
Oh my, yeah. Jack answered a lot. I put out all the Tinker Day, flipped all the Tinker Day pictures. All the fun and excitement. This one my picture. Yeah, this one's my figure. My.
School. What was your favorite part of school? Then?
Oh. I love how the fixed it down. It's probably monitored. Scalable now. There's probably some way to adjust it. And so what you're saying, you don't have to know. You can just have a little bit, but I think you should feel the equipment and. That's what I've heard. Oh, we can have. Yeah, I don't want you to ever be in the, oh, I wish I had researched, or, oh, I wish I had found out.
That's where we're gonna go. All right, I think Sky's mom wants to ask me something and she's outside somewhere, so.
Gone now?
They're leaving.
Everybody's gone?
Yeah, and I gotta,
What's all this?
Stuff not got out.
Why?
I don't know.
She didn't tell you what it was?
Because some of this, I don't know what out.
Did the students look at those books? Yes? What? I don't know where she is.
Sky and her mom. Yes. Yeah, both.
When you go to that other gym, to the GTC today,
Yeah, I don't really feel like going there anymore, but
try to, well, I mean, you should just look. When you go, try to talk to as many different coaches as you can. Like, just get the feel for who they are, what the place is, blah, blah, blah.
Yeah.
Take. Take. Come on, take. Take. I can hit. Take. 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 Oh. What? So what would I have to gain by going to Bible?
You mean by going to GTC?
Yeah.
Well, maybe you'll get there and you really like the gym or you really like the coach and you're like, this guy's cool. I like him better than Coach Keegan. I want to be here. You don't know until you go, which is my point. So, oops, this needs to stop.
Then I lose everybody. Because here's what there's only one thing I could do with the gym that